Hi guys, welcome back. Today we're going to take a look at solving subtraction equations. Very similar to what we did just the other day with solving our addition equations. We're just solving a different equation now instead of adding subtraction one. So here we're going to take a look at our vocab, our addition property of equality. It says basically the same thing as our subtraction one did. I can add any number that I want to one side as long as I'm adding the same number to the other side to keep it balanced or to make a true statement. So again, I drew the little balance to help you keep thinking of that equals as a balance sign. 7 minus 3, which is 4. So they're balanced. So what I'm saying is I can add 3 more back to this side, which would give me 7. I can add 3 to this side, which would also give me 7. So I still have a true statement as long as I do it to both sides. If I only added it to one side, this side would be heavier, my scale would tip, and then we couldn't keep our equal sign here because that's not true. You're going to see a board that you've seen before. Yes, you're going to see this one a lot. I'm going to keep drilling these rules into your head. They will get you through basically the rest of your schooling career because you need to know how to solve equations. What are the two things you need to know when solving equations? You need to keep it balanced. Both sides, do whatever you do to one side, do to the other. And you're trying to isolate the variable. That's how you're solving it. Once the variable is all by itself, you have your answer. The other thing I briefly want to look at here for subtraction equations is fact families, because there's one little trick that will solve you a whole lot of headaches when you're solving these equations, is if you remember your fact families. Back in elementary school, you probably talked about this. You know that 2 plus 4 is 6, and then we can flip it around for our subtraction. 6 minus 2 is 4, 6 minus 4 is 2. They're what we call fact families. All the same 3 numbers, but in a different order. So what you'll notice, ideally, is I can switch out my minuend, which is the second number, and my difference, and still wind up with a true statement. Here I flip-flop these 2 numbers. It's still a true statement. This is going to come in handy for subtracting our variable instead of the other way around. It's going to make it a lot easier for you to solve the equations. So we're going to take a look at a few examples here, keeping in mind our rules here. This one here, actually the easiest thing that I would do is I would actually change this into an addition equation. We know that when we subtract, it's the same as adding the additive inverse. So since I'm subtracting a negative, I would actually just rewrite this. Now I have m plus 8 is equal to 34. This is what we've solved yesterday in the other video, solving addition equations. So now I just need to subtract. If I subtract from this side, I'm going to subtract from the other side as well. I've isolated my variable. 34 minus 8 gives me 26. And again, you can plug it back in to make sure that you're right. Over here, we have a pretty simple and straightforward one. S minus 42. How am I going to undo my subtraction? I'm going to undo it using addition. If I add 42 to this side, I also have to add 42 to this side. Since we were taking that away, adding it in makes it cancel out, so I'm left with only S on this side. When I add these up, I wind up with 956. Then to check if you're right, you can always just plug that back in for S, and you should wind up with a true statement. All right, over here you'll notice I have an exponent. So whenever I have operations that I need to do, we want to do those first to make this a little easier on ourselves. So 2 squared is 4. We want to simplify that. 4 is equal to x minus 15. Now all I have to do is undo my subtraction. How am I going to do that? With addition. If I add 15 to one side, I need to add it to the other side as well. So over here, my 15s cancel out. I'm left with an x. 15 plus 4 gives me 19. So x is equal to 19. And again, you can plug it back in there and do your subtraction to make sure you're right. 19 minus 15 gives me 4. It checks out. That one is correct. This one is a little more complex. Again, you want to combine your like terms. However, what we want to keep in mind is that we need to pay attention to what our signs are. So the first thing I'm going to do is actually rewrite this by adding the additive inverse and adding the additive inverse, just so that we don't get confused with what it is that we're doing. So now if you look, I have a negative 4 plus a negative 9 that I can combine. So what do I get when I combine those? I get a negative 13. Now I've rewritten it as an addition equation, so I can get rid of it by subtracting, but I'm subtracting, remember, it's a negative 13 we want to take away. So I'm subtracting negative 13, which you'll recall is the same as adding the additive inverse or adding 13 to both sides. So those are going to cancel. I'm left with n. I've isolated my variable. 13 plus 13 gives me 26. And again, this would be one that you might want to check because it could be very confusing, making sure that you have your signs right up here. So go ahead and plug it in. 26 minus 4 gives me 22. 22 minus 9 gives me 13. It checks out. So let's take a look. Here is the one where I showed you the trick with the fact families that tells me I can flip-flop these two and still have a true statement. Here I'm subtracting the variable. This would be very difficult to solve, and it would become a multi-step equation, which we don't want right now. We'll take a look at those later. So I'm just going to flip-flop my two numbers here. I'm going to have 2 minus negative 8 is equal to s. Now all I have to do is do the math. So remember, when we're subtracting, we add the additive inverse. Negative 2 plus 8 leaves me with a positive 6. So s is equal to a positive 6. And this is definitely one where I would go back and check your answer just to make sure that you're correct, because I see a lot of mistakes happen here on these ones. If you're confused, feel free to go back, rewatch the video, or post a comment. You can send me an email, or we can just talk about it in class tomorrow. Have a great night, and I'll see you tomorrow.